Today we're going to discuss about loops in C programming language. We use loop constructs when we need to perform an operation repeatedly. There are different ways to do it: while, do while, for, recursion, etc. So I'm going to create a new project in Visual Studio. I'm going to write a simple while loop in this program. I'm going to declare a variable a int a equal to 0 while a less than 10, printf hello world. A equal to a plus 1. So let's see the output of this program. So I'm going to put a breakpoint here. So I got the output. So let's see what is happening. So from here to here is the loop. So this is the while keyword. In the parentheses, I have given the condition which has to be true to execute this particular piece of code. So as long as this condition is true, the program will be executing this particular two statements repeatedly. So what we are doing, we are checking if a is less than 10, do this. So until a is equal to or greater than 10, execute this two lines. So that's exactly what happened. So inside that, what we are doing is printing hello world. At the same time, we are incrementing a. Initially the value of a is 0. So after executing the first iteration, a will become 1 because 0 plus 1 equal to 1. Next time a is going to be 2. Like that, up to 9 this loop will get executed. When a is equal to 10, this condition becomes false and we will come here. We will exit out of the loop. So this is the condition and these are the statements which are repeated. Do while is very similar to while except in one fact that these statements are executed before the condition checking. A is incremented first and then it is being checked. To understand the difference, instead of 10, I'm going to put 0 here. So if this was a while loop, these statements won't get executed at all. But in this case, this condition is checked after the execution of the statements. So in this case, the print of hello world and a is equal to a plus 1 is executed once. So we got one hello world. Let's see this in the case of while loop. So I'm commenting this out. So I'm commenting this as well. While a is less than 0. In this case, the condition is checked before executing this. and only if the condition is true it is executed. In the case of do while, the condition is checked after execution, after the execution of repeated statements. So in this case the condition is false because a is already equal to 0, so this loop won't get executed even once. Let's see that. So we didn't get any output. Our execution is reached here. That's the difference between while and do while. So you have to write do first, then you have to write the statements which are repeating, then the while with the condition. Like in the case of if and else if, etc., this is evaluating into a 1 or 0. So for example, if I give 1 here, this will get executed always, and if I give 0 here, this will never get executed. So whatever conditions we give is evaluating either into a 1 or 0. It can be a return value of a function, it can be an expression which is evaluated to a boolean value, like a is less than 0. Now let us see for loop. So this is the exact equivalent of the while loop we have written before. So I'm initializing a equal to 0 here. I'm checking the condition a is less than 10, and I'm incrementing a here. So this statement was inside the while loop in the case of while. In this case it will come here. So this is the condition which should evaluate into 1 or 0. This is a statement which initialize the variables. This is where we increment a. So let's execute this. So we got the same output which we got in the case of while. So it is nothing but 10 times the execution of hello world. So now we're gonna see return, break, and continue. So these three statements will help you to break or stop the execution of loop in the middle. Let's see how it is done. So what we are going to discuss is common to all loop constructs, including while, do while, and if. So in this case, first we're gonna see return. If a equal to 5, return 0. If a equal to 5, what I'm telling is return 0 from this function. So stop executing the loop then and there itself whenever a equal to 5 and return from this function. So none of the statements after this will get executed. Whatever we are writing here will never get executed. So from here we are ending the function altogether. So let's see it. So I'm gonna do a printf test hello here. In this case, this printf test hello will never get executed because whenever a is equal to 5, we are returning from the function. If I put a breakpoint here, I will never get that breakpoint, so I'll put a breakpoint here. So I reach that breakpoint, I'm gonna press F10. As you can see, the execution jumped to the end of the function. It didn't reach here, which means that those instructions are not executed in this case, and we never got anything printed. Whenever we call return from a function, at that point we are ending that function execution. The statements after that is never get executed. It is true even outside the context of loop constructs. Now let us see continue. So we have two printf statements, one before continue and one after continue. So we are executing a statement continue if a equal to 5. So whenever a is equal to 5 inside the loop, we are executing continue. So let's see the output of this program. So this is the output of this program. Let's see from the beginning. So for 0, we are printing before continue and after continue. So 1, 2, 3, 4, except 5, for all other values, we are printing before continue and after continue. In the case of 5, we don't have after continue, which means that once the statement continue is executed, rest of the statement in the loops are discarded and the loop is restarted. So it's very important. The loop is restarted and this statement is not executed when continue is executed. So let's debug and see it once again. Stop debugging. So I'm putting a breakpoint here as well. So F10. So a is not equal to 5 in this case. It is a first iteration. So now continue is not executed. We are executing the printf F10 again. Loop is going to repeat. So printf again, a equal to 1 this time. Again, no continue. So printf is executed. So like that, 2, 3, 4, next is 5. So in this case, continue is executing. So this is continue. So now I'm going to press F10. So this printf didn't execute and the loop is restarted. So now a is 6, F10, F10. A is 6, so condition became false, so continue is not executed. So whenever continue get executed, rest of the statement in the repetition braces is not executed and the loop is restarted. Now it is very easy to understand break. So in the case of break, the loop is not restarted. So it's very similar to continue. So if I put a break here, break. So in this case, rest of the statements are discarded along with the loop. So loop is not restarted. So let's see the output of this program. So I'm removing these breakpoints. In this case, we got 0, 1, 2, 3, 4, 5, and then test hello. So test hello is outside the loop. So after 5, the entire loop is discarded, not just this printf. So this printf is discarded as well. So from here the execution came here. So in the case of continue, the loop was restarting. We discarded this statement and the loop is restarted. So in the case of return, the entire function got discarded and this entire code didn't execute. In the case of break, this is not executed as well as it came out of the for loop without completing the loop. Now let's see another method of looping called recursion. So recursion is nothing but calling a function from itself. So here is an example. We have a function called func which takes an integer as input. The first thing we are doing in the function is printing that input. Then what we are doing is we are checking if the input is 0. If the input is not equal to 0, we are calling that function itself by decreasing the value of input by 1. If the input equal to 0, we are returning from the function. So let's see the output of this program. So the output of the program is 10, 9. It's just like the loop. So it's in the descending order. So let's see what happens. I'm calling this function with input value 10. So initially it has printed 10. So that is the value. We are getting it here. Now I'm checking if input equal to 0. No, input equal to 10. So I'm not returning from the function. So what I'm doing next? So else input, I'm calling input again with 10 minus 1. So again this function is getting called with the value 9. So which is 10 minus 1. I'm printing 9. It is not equal to 0. So I am again reducing the value of 9 by 1, which is 8, and calling the same function. So at last the value will get reduced and input will become 0. In that case, I will return from the innermost function. So as I mentioned, this is another way to loop. So there is a big disadvantage with recursion. I'm not getting into the details. So all I wanted to show is the call stack of the thread when input equal to 0. So I'm going to put a breakpoint here. So now I'm going to show you something new which is called call stack. So if you look at the call stack, so you can see that the function has been called 10 times on the stack. So this is not good. This repetition is not good. So we will see the reasons later, but we have to understand one thing right now, which is recursion can cause a problem called stack overflow if it is not used correctly. So now we are going to see a program which find the factorial of a number using recursion and using for loop. So let's see the recursion method first. So this is a function which is taking the input, which is the value for which we need to find the factorial. So if the input equal to 0, I'm returning 1 because 0 factorial is 1 by definition. If it is not equal to 0, I'm returning input into the same function with 1 decremented from the input, which means that, for example, if I'm passing 4, I'll be doing 4 into 3 factorial. Like that, I'll be doing 3 into 2 factorial and 2 into 1 factorial, etc. So that is the logic. So the same thing I have implemented here with the help of for loop, no recursion. So again, I'm returning 1 if the input equal to 0, which is the definition of factorial. Now in the case of for loop, we have result equal to 1 and suppose input equal to 4. I'm initializing a variable I equal to 1. So I is less than input, which is 4. Now I am incrementing I after the execution of this statement. So what is result? Result is 1. Initially I is also equal to 1. So 1 into 1 equal to 1. Now I am incrementing I, as I mentioned. So I became 2. Result is 1 now. So 1 into 2 equal to 2. Like that, 3 and 4. Result will become 24 at the end. So let's put a breakpoint and debug each functions. So I'm pressing the play button. So I'm pressing F11 to go into the function. So input equal to 4. So first we're gonna see the for loop. I'm pressing F10. Result equal to 1. So input equal to 0, which is false at the moment because input equal to 4. So in the watch window, we're gonna put the value of result and value of I, which is not defined at the moment, and input, which is equal to 4. So I'm going to press F10 again. So I got I equal to 1. So result became 1. So I became 2. So 1 into 2, result became 2. Now I became 3. So 2 into 3, result became 6. Again I am executing the loop. I became 4. Now 4 into 6, result became 24. Now I equal to 4, so the loop will get exited. So loop is not executed after that, and I am returning the result after. So now let's see the equivalent function. Exact same operation we are doing with recursion. F11. So F10, so input equal to 4, which is not equal to 0. So we are going into the return statement. So I'm going to press F11. So in this case, when I pressed F11, this function got restarted. As you can see, the function got restarted with the value 3. So input is 3 right now, if you look at this. So I'm going to press F10 again. So F11. So now the input is 2. I'm going to press F10, then F11. Now the input equal to 1. Now again F10, F11. Now the input equal to 0. So we will return 1. So where is all the multiplication happens? So the multiplication is yet to happen. So F10, again F10. So this is the first multiplication which is going to happen. So the function is returning. So this was a 0 which we passed. So we got return value 1. So now this is 1 into 1. So we got returned 1. So 0 factorial 1 into input 1, which is a 1 factorial. So F10 again. Now we have input equal to 2. So 2 into 1 factorial. So this is going to return the value of 1 factorial, which is 1. So 2 into 1. So F10. So now the input equal to 3. So now 3 into 2 factorial. F10, F10, like that, 4 into 3 factorial, which is 24. So we got 24 printed. We also have seen that the debugging of recursive function is also a little bit tricky, unfortunately. So there is a debugging challenge as well with recursion. So try to avoid recursion as much as possible in production code. Now let's go back to our slides. So we have seen while loop. So inside the parentheses we're gonna give the condition, and inside the braces we're gonna give the instructions to be repeated. So do while we have seen. So do while will execute the instructions to be repeated once, then it will check for the condition which is to be true. So it's very similar to while, except that it will execute the instruction to be repeated before checking the condition. For loop, it's very similar to while. So initialization, things to be executed before the loop starts. Done only once, which is like statement I equal to 0. The condition to be checked before the execution of loop. Only if that condition is true, the loop will get executed. Increment, the statement executed after each loop, like I equal to I plus 1 or I plus plus. We have seen return, break and continue, different uses of it. Return will stop the loop and return from the function. Break will just exit the loop, not exit the function. It won't exit the function, but just a loop. Continue will exit that particular iteration of the loop and start the next iteration of the loop. So we have seen the demo. We have seen recursion function calling itself not recommended due to stack overflow, debugging and other issues. So we have seen the recursion factorial program. Also we have seen the for loop equivalent of the same program. And that's it. Thank you very much.